Okay, so here we have a variety of measurements that we want to put onto this circle. So they tell us that F is the center, GI is the diameter. Yep. The measure of the arc G to H is 65 degrees. Then we want to say what is the rest. So what is the central angle? Well, I think this should just be the same as the arc length. This is not typing in. So I'm going to call this GFH, the central angle that's producing this arc length of 65 degrees. So with this, we're saying 65 degrees is the length of this arc, and we're saying that there's 360 degrees of length around the outside. So you can use degrees as like the angle on the inside, or you can use degrees to signify like the amount of curve around a circle. It's kind of two uses for the same unit. Says give a minor arc. So there are, I count 1, 2, 3, 4 different sections around the circumference that have been broken up. So there's 4 arcs. A minor arc would be any of the smaller ones, any of them that are like less than 50%, which is actually, I think, all of them. It says give a semicircle. So the only semicircle I would see would be like G to I, right? That's the only one that goes halfway around. Semicircle, you need to go halfway around the circle. They find the measure of GJI. So GJI, well, it's a semicircle. So they're calling it GJI. I wonder if that's what I need to do. We'll see. So it should be 180 degrees. And the measure of GFH, well, that's what's already been recorded. That's that 65. Try and see if there's any issues in there. Semicircle. Okay. So GJI. Did they want it like that? So I don't really have much to say about that. I'm not really sure why they were picky about having 3 letters there. I don't think you need it. So like GI, if you have that semicircle notation above it, that is telling you you're going from G to I. Maybe this just specifies that it's going in this direction versus GHI would be a different one. And if you just said GI, you wouldn't really be able to tell if you're talking about the one on the right or the left. So possibly that is why they wanted that middle letter. That would be my best guess. And question 2 here, it says, as part of a survey, 1,600 people were asked to name their favorite sport to watch. The table below summarizes their answers. This information is also presented as a circle graph. So it's like a pie chart. Find the central angle measure X for the baseball slice of the circle. So we just want to say, what is the angle here? Well, presumably everything has been divided up evenly. So like 2 spots that were the same size would have about the same amount of people. If we just look for the total number of people first, so let's figure that out real quick. So the total would be, we'd have 8, 9, 28, 1,028, 1,056, 56, 1,200, 1,300, and 12, 13, 12, 13, 30, 13, 40, 14, 40, 15, 40, 1,600. I think there's 1,600 if I add up all these numbers. If I'm not mistaken, there should be 1,600. So what we're going to do with that information, we're going to say that there are 1,600 people, and we are just interested in what size of a piece is the baseball part. So 256 out of 1,600. So this is some proportion. Now, based off the picture, I would say, well, it's less than a quarter. Like basketball and baseball together appear to make up like just about 1/4 of this circle. So it's like less than a quarter. If anything, it's like a third of that quarter. So it's probably like a 1/12 of the whole thing. Maybe if you did baseball 12 times around, it'd fill up the whole thing. Is kind of my rough estimate. Now, whatever that fraction is, so if I'm estimating correctly, it'd be roughly the same as 1 over 12. That fraction should be the same fraction as the angles for baseball. So baseball has an angle of x. We don't know it. That's what we want to find out. But it's out of some total, right? It's out of the total when you go all the way around. When you go all the way around, you have 360 degrees. So if this is like 1/12 of the amount of people that are represented, if it has like 1/12 the area, I guess, of the graph, then we would expect that it would also have 1/12 of the entire um, 360 degrees. Okay, now I'm just saying 1/12. I don't know if that's a perfectly accurate number, so we'll check real quick. And actually, I'm going to do it the other way around first. 6. Okay, so I guess I was off. Actually, quite significantly off. That doesn't seem right. It says that that's a sixth of it. I think you can make that with 6 of those. Maybe something else was off. I'll just add them up real quick. 448, 480, 128, 6, 128, 60. Okay, so it was 1600. So we have 256 out of 1600. Right. Maybe this picture in the graph isn't to scale because that doesn't look like a sixth of the whole thing. I don't think I could add 5 more of those and make it all the way around. So I guess the picture is not totally to scale. Okay, well, regardless, so we get 0.16 when we simplify that fraction on the left. So I'm going to end up with 0.16 equals x over 360. Now, if I multiply both sides by 360, then I will get x by itself on the right. Okay, so like this 0.16 number would suggest that this amount of 256 out of the 1600 is 16% of it. So we want 16% of the full 360 degrees. That's what we're going to be doing. We're going to say 0.16 times 360 gives us 57.6. Yeah, so once again, that just doesn't look right based off the picture, but we'll check. Unless I was misreading something. I already told us there was 1600. The central angle measure, do not round. Oh, that's why. I was just misreading this. I was using the baseball number, not basketball. That's why everything seemed off. Okay. I want to do 128 out of 16. 0.08, so we want 8% of 28.8. Okay, so half as much. Okay, there we go. Good. So we're just figuring out what the proportion of the total is and then applying that to the angle itself. So the circle below has a center K. It has a radius of 3 centimeters. Given that this angle is 60 degrees, find the length of the major arc, LNM. Well, okay, so this is 60 degrees out of 360. So if you think about that as a fraction, 60 out of 360 would be like 1/6, right? So if we have if we have this circle here, you have 60 degrees. Well, that is going to be 1/6, right? If I continue making 60-degree chunks, I would make 6 of them. Okay, if our radius is 3 centimeters, we know that our circumference is 2 times pi times the radius. So in this case, it will be 2 times pi times 3, which will be 6 pi. It says write your answer in terms of pi. So I'm not going to go 3.14 and do anything. I'm just going to say 6 pi for the circumference. Well, if the circumference is 6 pi, if that's what goes all the way around, that means each of these little sixths of the circumference should be pi. Right? Pi in length, 3.14. I think we're doing centimeters. So if they're asking for this major arc that goes all the way around, excluding this one piece, it would be 1, 2, 3, 4, 5 pi's. So 5 pi, once again, we're measuring a length that is wrapped around a circle. It doesn't change the fact that it's a length, that we're not doing an area or a volume. We're just doing a one-dimensional measurement of length. Okay, problem number 4 in this one. We have a central angle given to be the same in each of these, 135 degrees. Different radiuses, 1, 2, and 3 millimeters. And now they want to say for each circle, find the length of the arc that is intercepted by the central angle. So like the arc from A to B, the arc from D to E, and the arc from G to H. So we'll do the same thing as before. We'll say that 135 degrees out of 360 is some sort of fraction that we should be able to reduce. What might that be? So if I divide them both by 5, I would get 27 up top, I think. And I would get 72 on the bottom. I believe that's correct. If I divide that by 3 on the top and bottom, I would get 9. And what would I get here? 10. Let me see if that actually reduces. What are my numbers? 27 over 72. Okay, so it was 9 over 24, and I guess that would still reduce further to 3 over 8. Okay, so this is 3/8 of the circle. Let's look at the picture, see if that makes sense. So if we had half of it, that'd be 180 degrees. And if we wanted to cut it into quarters, we could do that and make fourths. And it looks like this would be 1, 2, 3/8 if we cut it into eighths, right? We took that circle, we go fourths, and then we go eighths. It appears like the section that we're looking for is like 3 of those eighths. So that checked out. Okay, so we want 3/8. Now, if we can figure out the full circumference for each of these, then we just need 3/8 of that circumference. So for the first one, 2 pi times r is going to be equivalent to 2 pi times 3. Or 6 pi. For the second one, the circumference, so we'll say circumference 1, circumference 2. Second one's going to be 2 pi r, but the radius is just 1. So we're just going to get 2 pi. And for the third one, we have 2 pi, and I think the third one was a radius of 2. So we'll end up with 4 pi. Okay, so what we want, our little section, our 3/8 of the circumference for the first one will be 3/8 times 6 pi. Then we'll have 3/8 times 2 pi and 3/8 times 4 pi. Okay, finally, we just want to simplify whatever we can. So I think on the top, well, let's wait for the top one. On the bottom, we have 4/8 is the same thing as 1/2. So I think this is going to be equivalent to 3/2 pi. 2/8 is the same as 1/4. So we're going to have 3/4 pi. And over here, 6/8 would be the same as, what would that be? Same as 3/4. So we times that by 3 and we get 9/4. Okay, so let's try that. AB should be 9 pi millimeters. So 9/4 times 3.14 millimeters. DE should be 3/4 meters. And then GH was 3/2. For each side of the circle, for each circle, find the ratio of the arc length to the radius. So divide this by its own radius. Okay, so this one divided by 3 would, just take this from 9/4 down to 3/4. This one divided by 1, because that was its radius, would just be the same number, which same as the previous part, which makes me assume that we're going to get the same for all three. GH was 3/2 pi, and we divide that by 2. So dividing that by 2 would change it into 3/4. Right? 3/2 is equivalent to 6/4. And if I was to cut this number in half, then it would be 3/4. The ratio suggests which of the following? The ratios increase by 3 pi over 4 units as the radii increase by 1 unit. No, the ratios stay the same in each case. Doesn't matter what the radii was. The length of the arc intercepted by the central angle is 3 pi over 4 units more than the radius. Once again, no, these are ratios. It's not saying it's like something plus 3 pi over 4. The ratios by 1 unit. What does this one say? The radius. Not reading this right. The ratios increase by 1 unit as the lengths of the intercepted arcs increase by 3 pi over 4 units. I don't think so. I think all the ratios just stay the same. The length of the arc intercepted by the central angle is proportional to the radius. Yes, I think that would be it. So this is the length intercepted by the central angle, the top thing in each fraction, and the radius is the bottom thing. So they're saying that they all just follow this proportion. They are all proportionate by 3 pi over 4. So the length is always whatever that number is, 0.75 times pi. So 3.14 times 0.75. So the proportionality that's constant here in this example is that the intersected arcs are always 2.355. That's what we get when we multiply 3/4 times pi. It's always 2.355 bigger the length of the arc than the radius. So whatever your radius is, you multiply that by 2.355 and you have your arc. That is what it means to be proportional, that we have like a similar multiplication going on to get from one to the next, from the radius to the length. Okay, convert 3 pi over 2 radians to degree measurement. So this is just based off the idea of that alternate numbering system for angles. So we start by kind of knowing about degrees, right? When we go around in a circle, we have 360 degrees. When we go halfway around a circle, we have 180 degrees. The alternate form of measuring angles is called radians. And this is a form that's kind of just better suited to circles because it has to do with circles more than just this number, which was kind of chosen for convenience. 360 wasn't really chosen because it has anything to do with circles. It's just chosen because it divides up nicely into different fractions. So if we want to do radians, we need to know what the definition of a radian is. So when you have a full circle, you have 2 pi radians of angle. Okay, and as a reminder, what a radian is, it's when you take the radius, so whatever that distance is, and you wrap it around the edge. So if this radius was like 3, then that arc length would be 3 as well. So you wrap around the edge the same distance r that you have from the center to the outside. The angle that makes is 1 radian. And there are approximately 6.28 of those around the outside of your circle. Sorry, I didn't draw that great. But there are 2 pi radians to go all the way around the circle. Which should make sense, right? Because that's what the circumference is. Our circumference is 2 pi r. So we would expect to get 6 of these little segments. Sorry, a little bit more than 6 of these little segments. 1, 2, 3, 4, 5, 6, and then a little 0.28 section. So we should have 2 pi worth of these things, right? We should have approximately 6.28 of these radiuses. Okay, so we should also have 2 pi radians. So the angle measurement, this thing that I'm calling a radian, the angle that produces this length around the edge, there should be 6 and then a little extra fraction of 1 as well. So that definition allows us to use what's called a unit conversion. So a unit conversion is just like if I wrote the fraction 1 meter over 100 centimeters. If I was to multiply this with like a certain number of centimeters, let's say I had 200 centimeters. Well, this thing just equals 1. This is just, something over itself. 1 meter is 100 centimeters. So when I put those together, when I put them over each other, it just equals 1, the fraction. So you're not really changing anything. But what you end up doing is you end up canceling out units. So we get rid of centimeters because it's on the top and bottom of a fraction. And then we just simplify all the numbers. So we say 200 times 1 divided by 100. Well, that would be 2. And it's 2 meters. It's 2 of whatever unit is left there. Okay, which makes sense, right? If I have 200 centimeters and every 100 centimeters is a meter, then I have 2 meters. Well, we'll do the same exact thing here with degrees and radians. So we will say that 360 degrees is equivalent to 2 pi radians. Okay. Radians being that other unit of measuring angles. Now we can either use that fraction or we can use this fraction. Just depending on what we're starting with. So for example, if we are starting with radians, so that's what this one says, convert 3 pi over 2 radians. So 3 pi over 2 radians. Well, in this case, you would want to choose the direction of the fraction that would allow us to cancel radians out. So to cancel radians out, you need radians on the bottom. If we had started with degrees, we would have used this fraction so that degrees was on the bottom over here. But we want these guys to cancel out, the radians and the radians. Now the numbers don't go away, right? I'm not saying the numbers cancel out. I'm just saying that the units cancel out. So we have 3 pi over 2 times 360 divided by 2 pi. So let's write that a little more cleanly. 3 pi over 2 times 360 over 2 pi. And we know that our answer will be in degrees. Well, our pi's will cancel out. 360 divided by 2 would be 180. So we have 3 times 180, which would be 360 plus 180. So 540 degrees. Uh-oh. 3 pi over 2 radians to degrees. What was off there? 3 pi over 2 radians. 2 pi radians for every 360 degrees. I guess I canceled out more than I meant to here, didn't I? There's 2 pi on the bottom. Should not have crossed out the other 2. Should only cancel out that. Okay. So in that case, we would still have, we'd have 360 divided by 2 and then divided by 2 again. So this should actually be 90. And my answer should be half as big. Should be like 270. Let's try that out. Right. So that would be it for Tuesday. The last one's only 3 questions, so I'll just kind of run right through it so that we do not hang out here too much longer. We can just kind of make this a short meeting. Sorry, I'm trying to get that recording to stop. There we go.